All right, so in this demo, we're going to start Wireblast in both listening and or receiving and sender mode. So let's do that. So this is the diagram. So we have the server 1, which is the one you see on the left side. It is sending traffic over this VLAN, sending it to the server, which is routing that back over another VLAN and should arrive here. So as you can see, we're sending 1,000,000 packets per second, and we are receiving 1,000,000 packets per second. So that works well, and you can see these numbers are the same as this graph here at the bottom. All right, so that works well. Now let's try and overload it a little bit. So if I press Q and then edit, and then we'll do maybe 3,000,000 packets per second. And what we'll see is that the second server here, the one that is bouncing it back, the Linux kernel will tap out. And so you can see that both things here. So let me start at the top. So first of all, if we go back, you can see we're sending 3,000,000 packets per second. But we're really only receiving about 2.6 million packets per second. And what you typically see on Linux here is just like all these soft IRQs. And as you see, there's almost no idle left over. And there's a few that run idle, but those are receive queues that receive no traffic. But yeah, this is an example of where you can send and receive on the same machine. We can make this thing even worse for it. So let's go to UDP and we'll do, let's say 1,000 flows, and let's go back real quick, and 64 bytes and I don't know, 10 million or something. There you go. So now we're sending at 10 million packets per second, which really is only 7 gigs at 64 bytes. Now you can see this machine is totally dead. There's literally only one core that, for whatever reason, gets no traffic. All the other ones are working as hard as they can, and there's no idle time left, which you can see, because we can send 10 million, but we're only receiving 3,000,000 packets per second. And again, that's a limitation of the Linux kernel. Should we have a real AFXCP forwarder on this other machine, that would look a lot better. All right, I hope that example was useful.